Hello everyone, and thank you for tuning in. Now, to get the most out of this practice test, please pause the video to work each problem before revealing the answer. You can also download a copy of the practice test through the description link down below. Now, by watching this video, you are definitely increasing your chances of getting a high score on the final exam. Now, I'm going to work through the problems quickly but thoroughly so the video doesn't become longer than it has to be. So you don't have to watch the entire video in one setting. You can skip through frames and or take a break as needed. So let's get started. Section 3, Factoring Polynomials. Number 27, factor completely. So what is the correct answer? Choice D. So here we were asked to factor completely a polynomial here, and notice this polynomial has 4 terms, and whenever you see a polynomial that has 4 terms, that's usually a clue that you're going to be used what is called a factor by grouping method, where you're going to pair these in groups of 2 and then remove the GCF from the groups of 2. So let's go ahead and group the terms together in 2 pairs. So now we're going to look at the first group and say, what is it that these 2 terms share in common? Well, we can see here that the GCF between the 2 of them would be y squared, because you have 2 y's here, and I know I can take 2 y's from the first term because it has 3 y's. So the GCF between those 2 terms would be y squared. So the y squared goes on the outside. So what is left of this term when you take 2 y's out? Well, you have 1 y left. When you take 2 y's from this term, well, you would have the negative 2 that's left. So GCF on the outside, and then you would write what's left in parentheses. Now next we want to focus on that second group to look at these 2 terms and say, what is it that they share in common? Well, we can see that they share a 3 in common, but remember I told you in class that whenever a term starts with a negative, that you're going to factor out a negative. So I'm going to factor out a negative 3. And so when I take the negative 3 from the first term, I'm left with y. And remember, when you factor out a negative, you have to change the sign behind it because that's the only way it's going to work. When I take the 3 out of the 6, it's going to leave me with 2. So that's y minus 2. And when you use the factor by grouping method, you'll notice that each group share the same GCF in common here. So we can check to make sure whether we brought down the right sign or not. So let's go ahead and do that. Negative 3 times y equals negative 3y. That's correct. And then negative 3 times negative 2. That does give us positive 6. So moving on, the last thing we need to do is just to remove the common factor among them. So if you look at this factored form, I spy, I see something that they have in common. In other words, what is it that this first group and this second group, what is it that they have in common? Well, I can see that they have a y minus 2 in common. And then what is left once you take it out, you can actually see it. It's there in color. Y squared minus 3 would be left once you take out their common binomial factor. So that is the correct factored form of this polynomial. Number 28, factor completely. So what is the correct answer? Choice C. Okay, so here we were asked to factor this trinomial. The first thing you should do when factoring polynomials is to look at all of the terms and see if there is a GCF. So in terms of the numbers, you look at the smallest number and you ask yourself, okay, is there a 2 inside 30? Yes, there is. Because 2 times 15 is 30. Is there a 2 in 108? Yes, there is, because 2 times 56 is 108. So 2 would be our number. Then you look to see, does everyone have an X, all the terms? Yes, they do. At most, 1. Does everyone have a Y? Yes, they do. At most, 1. So therefore, the GCF between these terms would be 2xy. So we're going to take the GCF out, and what's left goes in parentheses. Notice we are left with a trinomial, so we need to factor that trinomial into two binomials. Remember, if the back end is a positive, that means the signs are the same. What kind of signs? The middle term tells us that they're going to be two negatives. So we are looking for a pair of numbers that when we multiply them, they equal positive 54. Those same two negative numbers, if we were to add them together, they would equal our middle term of negative 15. So what are those two pair of negative numbers? That's correct. Negative 9 and negative 6. So we're going to just go ahead and factor the trinomials, and there we have factored it completely. Number 29, factor completely. So what is the correct answer? Choice A. Okay, so we're asked to factor this trinomial. And first of all, let's take a look at the first and the last term. When you notice the first and the last term, such as in this case, they are numbers where there's not a whole lot of possibilities of their factors. For example, factors that give me 3 are just 1 and 3. There's no other factors. Factors that give me 14 would be 1 times 14 or 2 times 7. And of course, you would always try the 2 times 7 first before you would ever try the 1 times 14. So since these two don't have a lot of possibilities of other factors, the quickest method for those type of trinomials is just to simply use trial and error. So let's use trial and error method to identify our pairs of numbers. So in terms of their signs, if the back end is a negative, recall that the signs are going to be different, and this middle term sign tells us that make sure that the larger number is a negative and that the smaller number is positive. So if we look at again in terms of factors of the last term, it's 2 and 7. We're going to try those first. With the first term of 3x squared, there's only one way that you can split that up into binomials, and that would be a 3x in one and x in the other. So we can go ahead and plug our numbers in with the 2 and 7. Remember, 7 has to be negative and 2 has to be positive. So it's basically only two options as to how this can be factored. You can have the negative 7 first with the 3, and then the plus 2 with the x, or you can try it the other way with the plus 2 with the 3 and the minus 7 with the x. So it's got to be one or the other. So let's figure out which one it is. Here's a quick way you can just identify the answer, even if you have multiple choice tests. Is just simply combine outer and inner. And if outer and inner, if it gives you your middle term, then you have the correct pair. So let's go ahead and check out the first one. So if we do outer, 3x times 2 equals 6x. and negative 7 times x equals negative 7x. So when I combine those two together, they equal negative x. So notice my middle term is not negative x, so that pair does not work. Let's try the last option here, and if this option doesn't work, and that is the only time you would then try the one with the 1 and 14. So if it's a composite number such as 14, always try other pairs other than the number with 1, and when those pairs don't work, then you can try that number, in that case with the one with the 14. But let's continue with our last option of the 2 and the 7. So outer 3x times negative 7 equals negative 21x. 2 times x for inner gives me 2x. So when we combine them, we do get our middle term of negative 19x. So that is why choice A is the correct answer. Number 30. Factor completely. So what is the correct answer? Choice B. So here we were asked to factor this binomial completely. So the first thing you should do when you're asked to factor is to see if the two terms have anything in common. And here they do, because 25 times 4 equals 100, and 4 times 4 equals 16. So what is it that they share in common? They share a 4 in common, so we're going to take that out and then write what's left in parentheses. So notice what I have left here is a difference of square. Recall that a difference of square is going to factor into something plus something and something minus something. So one easy way to find that is to basically take the numbers and find the square root of them. The square root of 25a squared is 5a. The square root of 4 is 2. So the two numbers I'm going to be working with is 5a and 2. So that's going to be 5a plus 2 and 5a minus 2 with my GCF of 4 on the outside. Number 31, factor. So what is the correct answer? Choice B. Okay, so what we were given here is a binomial, and there's something I noticed about this binomial. I see a variable raised to the third power. So that sort of kind of gives me a clue that what I may have here is a difference of cubes, and to check, we can just simply ask, is 27 a perfect cube root? Yes, it is. Is 64 a perfect cube root? Yes, it is. And the fact that we have a minus sign between them, that is called a difference of cubes. So remember that chant that we learned in class? Oh yeah, I did not forget that. It goes a little bit something like this, where I told you that it factors into a binomial and a trinomial, and what's inside that binomial and trinomial is a, then b, a squared, a and b together, b squared. Again now, a, then b, a squared, a and b together, b squared. One more time now, a, then b, a squared, a and b together, b squared. And yes, and I told you also that the signs are SOP, which means same, opposite, positive. So let's take a look at that. So if you're given a sum of cubes and you notice that you have a plus sign between them, so when you factor that, your first sign would be the same as that, a positive. Your next sign would be opposite, which in this case a negative. your last sign always a positive. If you're given a difference of cubes, such as in the case of this problem, then again, your first sign will be the same, which is a negative, opposite, meaning a positive, and again, the last sign is always positive. So the next thing you need to do then is to simply find the cube root of these two terms. So the cube root of 27b to the third power is 3a, and that's what we're going to call a. The cube root of 64 is 4, and that's what we're going to call b. So plugging that into the formula, we have here a, which is 3b, then b, which is 4, a squared, 3b times 3b equals 9b squared. Multiply a and b together, 3b times 4 equals 12b. And then lastly, square b. If b is 4, 4 times 4 is 16. And your signs will be SOP, same, opposite, positive. So if our original binomial has a negative, our signs would be negative, positive, positive, which looks something like this, which is choice B. Number 32, factor using the zero factor property. So what is the correct answer? Choice C. Now recall, to use the zero factor property, the quadratic equation needs to be in standard form. And standard form is where all of our numbers are on the left side and 0 on the right side. So to get this equation in standard form, I would need to subtract 5x from each side and then add 3 to each side. So once we get the equation in standard form, our next step, step 2, is to factor this equation. So notice the back end here is a positive, which means the signs will be the same. What kind of signs? Well, the middle term tells us that there are going to be two negatives. So we're looking for two numbers when we multiply them equal 3. Well, the only numbers that is going to give me 3 is 1 times 3. So our two numbers are -1 and -3. So we can go ahead and factor that. Next, we're going to take each parentheses and set them equal to 0 and then solve for x. So with the first one, all I need to do is add 3 to each side, then divide by 2, and x equals 3/2. For the second one, all I need to do is to simply add 1 to each side, and x equals 1. So my two solutions are 3/2 and 1. Number 33. If an object is propelled upward from a height of 160 feet at an initial velocity of 144 feet per second, then its height h after t seconds is given by the equation -16t squared plus 144t plus 160. After how many seconds does the object hit the ground? So what is the correct answer? Choice A. So to solve this particular word problem, this is nothing more than an application of the zero factor property, because it asks after how many seconds does the object hit the ground. So the ground level is always at ground zero. So what you will need to do is to take the equation, set it equal to 0, and solve for x. So we were given this equation, but the first thing we need to do is to look at the terms and see if there's a GCF that we can take out. That is always the first step in factoring. And I see here that there is a GCF, and also I noticed that the equation starts with a negative. Remember in class I said that if it starts with a negative, we want to factor out a negative. So we're going to go ahead and factor out that negative 16 that they all share in common. So once we take the GCF out, notice we have a trinomial that needs to be factored into a binomial. So let's take a look at our sign rules. Remember, if the back end is a negative, that means the signs are going to be different. The middle term tells me to make sure that the larger number is the negative, which means the smaller number is going to be the positive. So we're looking at a pair of numbers that when we multiply them will give us 10. Well, I know that 2 and 5 will give us 10. However, that will not produce a middle number of negative 9 here. So the pair of numbers would be the 1 and 10, with the 10 being the negative 1 and the 1 being the positive. So we're going to go ahead and factor that into two binomials. Next, I want to take each parentheses, set them equal to 0, and solve for x. So taking the first and solving for x, we can see that x would equal negative 1 and the other x would equal 10. Now, since time cannot be a negative, we have to throw the negative 1 out. So therefore, the solution is 10. The object will hit the ground in 10 seconds. Okay, that's it for this lesson. Thank you for watching Math on PowerPoint tutorials. If you liked this video and found it to be helpful in any way, please like it and subscribe to my channel.